So, can models change the world? Can they? They can. They have changed the world, and they'll continue to do so in more and more significant ways going forward. Models are incredibly powerful. They describe the world around us, they set a path forward for our ideas, and they even invoke action of what we'll do next. I have a passion for modeling. I've done modeling for a long time. Anytime I have a big decision to make, I model it. The bigger the decision, the more I have riding on it, the more elaborate my model. I can think of if I'm going to move, if I'm going to change a job, if I'm going to buy a car, if I'm going to buy a house, even marrying my spouse. Yeah, I did that. I'm not going to share that one. Naming our children, statistical models. I did some of that. I created a little model when my wife got home. On her desktop was a counter to show the age of my son who we just brought home. Models can be fun, right? They can really be fun. But you can fall into traps. My wife often points out that I fall into this one. Paralysis through analysis. Anyone here guilty of that? Or biasing our models to give an answer that we want. That's another one that I fall into. But even when I fall into one of these traps, I learn an immense amount when I model. Because I think very deeply about the subject, the problem, the system, the issue, the challenge, whatever it is I'm thinking about. I think about what it interacts with, what things externally does it interact with, what are the outcomes, what are the scenarios, I might build another model. So then I started to think, when did I start doing this? When did I become such obsessed with modeling? And I talked with my wife about it. She goes, well, I said, I remember in 7th grade, I went to the middle school library and I got a book on design and drafting. This wasn't an assignment, this was something I just did. I was interested. I wanted to be an engineer, I wanted to build cool things, motorcycles, cars, I'm from Michigan. And so I went and I found it, and I took notes. And I thought, do I still have that? She's like, you've got drawings downstairs, these tubes of things, all that stuff. You probably do. So I went down, I went to the basement, I looked through some things, and sure enough, I found them within 5 minutes. These are 3 pages from my 7th grade drafting notebook. I was pretty excited when I found it, because I remember clearly getting this book. I took over 20 pages of notes in 7th grade on this, on my own, independent. What you'll find, and I found was interesting, is the principles in modeling, they're here. They're in this notebook, right? I found descriptive, structural, temporal, behavioral models. You see in this middle page, many different ways of doing it with an exclamation point. Many different ways of modeling systems. Many different drawings of one thing. My grammar wasn't so good in this journal, by the way. Another indicator I'd be an engineer, probably. But many different views. We talk about all the views. These are principles. These are things I advocate for when I talk to folks, when I mentor, when I even model myself. So then I started looking at my career, and I said, well, how did this come about? Well, after middle school, I got into drafting in high school. I actually drew 2 houses, complete set of prints that were built, and I got to go inside one of them, which was really exciting, which really set my path forward. You can see there's a red and green dot. That was a configuration management viewpoint issue. Working with a client, they put the fireplace on this wall, then that wall, then this wall, then that wall. Finally picked it. I didn't update the foundation plan and the footing. I was 16 though. But viewpoints, configuration management is vellum. This was all on the board. All drawing on the board, right? Eraser shields and brushes and stuff like that. Well, got some awards. Michigan State called me the first week in school and said, you want a job? I'm thinking it's got to be out in farms. I said, no, it's engineering services. We see you did some drafting. Do you want to work here? Oh, yes. So I went there and they had CAD. Oh. So then I started modeling campus buildings, picking up old sticks and remodeling them 3D, which was very exciting. Then all of a sudden I'm doing models for my peers in engineering classes. I'm doing models for professors coming to my dorm. I'm like, how did Dr. Foss go to your dorm room? I'm like, I'm modeling something for him. It was a lot of fun. So I left school with 9 credits left, but now I've got a job doing this. Then did distance learning to finish my degree. I did my capstone project with Ford, ended up working there. That was in manufacturing, value stream maps, lean manufacturing, dynamic control plans, CAD still, and process prints, systems dynamics, stocks and flows. Took some classes at College for Creative Studies in automotive design. Did some drawing, artistic. I do a drawing in a month. They wanted hundreds of drawings in a week. How is this possible? And then I saw some people doing it, I thought, wow. But I learned a lot about that kind of model. And now into systems, and that's what I really want to talk about the rest of this time, is systems modeling. In the next 10 years, we're going to see a significant change in how things are done. I'm convinced. It'll be changing every year. We'll see a big jump about how we model systems. Our models represent the systems out in space, right? But they don't today. Here's a simple model. 12 nodes, 12 lines. A boundary, right? Something that we don't always do so well. We have external interactions. Pretty simple, straightforward. More nodes. We have 20 nodes total. By the way, if every node here could connect to every other node, there are more configurations of this network than there are atoms in the known universe. That's hard to believe, but it's true. There's multiple configurations of this network right here. But then we add sensors. We add more to the systems. We add more cloud services. We fuse data, find new ways of serving, extend the boundary, add more, add more, add more. Cross-domain, research, education, energy, policy. Then we have this web of interconnected things. Do our models look this way? No, not at all. So we need to change it. Here's another thing, the rate of change. This is another thing that's significant. Internal to our systems, lines of code, off the chart. External, connectivity, Internet of Things, off the chart. Internal to our organizations, enterprises, digital transformation. How are we doing it? Off the chart again. Technology proliferation, the orange lines to the far right, it's just a vertical short line. It's out, it's adopted. Let's go. Now that it's adopted, what's going to emerge? How do other systems connect to it? These things just evolve and go very fast. When the rate of external change exceeds the rate of internal change, the end of your business is in sight. Jack Welch. Very fitting. Intuitively, we know this is true. So we must change. We have to change. How will we change? Well, we have enterprises. They give us systems, right? We have smart systems now. They're interconnected, intelligent, instrumented. They're providing continuous feedback. They're cyber-physical. They're agile, flexible, adaptable, right? They require updates, but not just software updates. Sometimes we need a hardware update before there's a recall, before there's a warranty issue, because we've learned something from the feedback the system's telling us. What we need are smart enterprises that are model-based, they capture knowledge, they leverage patterns, and continually learn, right? So we can rapidly respond. It's no longer the platforms out there, but it's the service. In automotive, there's kind of been this talk about automotive to mobility. And it's that kind of thinking now that we have to have. So, we're systems engineers, many of us. What do we need to do? We need to understand what is knowledge. Even within our handbook, we have knowledge management. The node size on this simple model that I put here is centrality. The nodes are sized by centrality. What's obviously the most central of everything? Knowledge management. It's kind of surprising, not? Next is project planning, and then stakeholder needs and requirements definition. And these are the feeds back and forth. The connections to all the other process areas. That's why it's so central. So, where does knowledge reside? It resides often in the minds of our subject matter experts, people with long careers who've got this experience. The picture here is from Moneyball. If you haven't seen the movie, I suggest you do. It's a great movie. The book's by Michael Lewis. And it looks at baseball. On the left, we've got scouts, experts, managers who identify talent to draft, right? They just are able to do that through their experience. On the right, we have analysts, engineers that were actually hired. This is for the A's. We start saying, how do you win games? You win games with runs. How do you get runs? It's on base percentage. And so there's this tension in the room, in the movie, about who's right and how do we do this. And the A's were very successful, winning a lot of games with a very low budget from a business perspective. And so this book is often in many different business schools. But we need to take this tacit knowledge, and we need to convert it to formal models, explicit knowledge in formal models. There's many ways we can do that, but that's the effort, and that's what we need to do. So how do we think about this? How can we think about it? What's the most complex adaptive system we can think of? Human, us. We are just able to adapt. How do we do that? Well, Kahneman wrote about it in Thinking Fast and Slow. He said we have system 1 or system 2, which is the fast and the slow, the conscious and the unconscious. Right? The fast works easily. It's low effort, quick judgments, patterns, chunking information, intuition, instinct. You ever been driving, 10 minutes goes by, you look up and go, how did I get here? That's fast thinking. That's your unconscious is taking care of it. Conscious thinking is slow. It's more laborious. Takes time. Formal logic, right? We often, as engineers, spend our time there, but we also flip between the two. And actually, there's a constant stitching between the two that goes on. And sometimes it's something that requires analysis later becomes part of a pattern that we can apply very quickly. So why wouldn't we model our enterprises after the same kind of thing? In fact, we should, right? What is the enterprise system cognition? A team of teams, right? They apply pattern-based methods. We think of both intuition and analysis. We can think of a playbook and then adaptable play. Back to sports again, a quarterback. There's a play, there's a script. If there was no play, he's probably going to get sacked, right? There's a play. And then things unfold and we learn from it. And we can adjust. We need the same thing in our enterprises. It starts to probably sound a little bit like product line engineering, platform engineering, right? What are those patterns? Not just at the small level, a screw and nut or bolt, but at a macro level, what is a car, right? So once we know and we have these patterns, we can apply them very rapidly. We can identify when things change. People can learn very quickly about what those patterns are. But eventually, we all need to move toward shared human understanding, right? That is, it's in the Vision 2025. All of our models are really about bringing us to an understanding that's consistent. Some of our models end up on board our systems, but many of them are just for us to learn, to plan, and to design with what's going to be the future. So we need this shared human understanding that's absolutely essential to what we do. And how do we enable it? Explicit formal models. Otherwise, things are fairly ambiguous when we communicate, when we talk. We need precision, and that's what formal models can do for us. Now, we have information and knowledge in formal models. We have a shared understanding of what we can do with it. Now we can start to talk about how we allocate the work. How do we accomplish what we need to do? And this is where we hear a lot about artificial intelligence, right? How can we apply machine learning, AI, natural language processing, etc. Yes, we need to do that, but we need to do that in combination with the human, with the engineer, who brings intelligence to this as well. And augmented intelligence is really about that combination. It's the human-machine collaboration. It was in 96 or 97 that Deep Blue from IBM beat Garry Kasparov in chess. And from that point, now AI beats a grandmaster. However, if you put a grandmaster with a machine, they'll always beat the AI, right? So we have that augmented intelligence, human plus AI is better than the human alone, and it's better than the AI alone. But Kasparov's law, he pointed out another thing that he observed when they had an open play in chess. That a weak human, let's say a novice player in chess, a computer, a machine, in better process, can be a grandmaster plus a machine in weak process. Also surprising. So process is important. It has a role, and it helps us. So, all these things are great if we can put them together. It is on a progression toward how we become a smart enterprise, capturing and formally modeling knowledge, many ways of doing that. Applying pattern-based methods, another level of maturity and understanding, and adding speed to the work that we do. We want to build shared human understanding, absolutely essential. Alignment and teams and synergy, all those things that we know make a big difference in our organizations. Just when we have alignment, you'll see when we have this within the engineering domain as well. And then we can employ augmented intelligence. But all those things are going to have to continually adapt and change. Back to the curves that I shared early on, when they just leap off the chart. That condition isn't changing. I often share a quote from Christopher Alexander where he talks about 50 years ago about how much things change. Things are going faster and faster all the time. Complexity is going up all the time. That was 50 years ago. It is not going to change. So we have to continually learn and transform. This needs to be a fundamental part of what we do. You can see here a quote, "Simplicity is complexity resolved." So simplicity is on the other side of complexity. So we have to wrestle with how do we work through this. It's not easy. Another quote from Einstein, "Any intelligent fool can make things bigger and more complex, It takes a touch of genius and a lot of courage to move in the opposite direction. And I often like to point out courage, because this is very contrary to the way that things are done today. Today, things are very siloed. Today, we are optimizing within our own little areas. It's harder to go out and to communicate with others and influence them for change. And that's what we need to do to really transform things. So, another thing that I like to recommend to folks that I've worked with or that are working in this mentoring is a course in model thinking from Scott Page, who's at U of M in complex systems. I took this from the course description. It says the evidence shows that people who think with models consistently outperform those who don't. You could probably all agree with that. And moreover, people who think with lots of models outperform those who use only one. And oftentimes, we use only one, or at least just ourselves. And then other areas, they use their one, then they use their one, and we don't talk, communicate. And so we need to learn how to better collaborate, communicate across those typical boundaries. So, lastly, models are powerful. Stated that. They help us understand our world. They provide a path forward for ideas of what we think the future can be. And they invoke action. Often they help us to take that next step. So I encourage you to model, use multiple models, and you can change the world. Thank you.